All right. Hi, everybody. Welcome to GDG Surrey and welcome to our um, first chapter of our machine learning paper club. Through this club, we hope to bring together a community that is interested in machine learning papers. And here we have Alka, who I will introduce shortly. And Alka will be leading these sessions with us. A little about GDG Surrey. We are a not for profit, community driven organization. We're all volunteers here, including the organizers and the participants. Uh, we try to keep most of our events as accessible as possible. That is one of the goals at GDG Surrey. And our other goal is to obviously bring people together as efficiently as possible. Anybody all over the world can join this community by going to gdg.community.dev/gdgsurrey. And once you have joined this community, you have access to all of our virtual events. And if you would like to visit us in Vancouver or in Surrey, you can also participate in our in person events. A little about the team. My name is Ria. I'm one of the co organizers of Google Developer Surrey. And here in the pictures, you see our core team members. This team is what keeps this organization afloat, and I am so grateful for the team that we have. It's been a beautiful journey for the past year since our inception, and we've just been having so much fun bringing people together and organizing these events. In these pictures, you see us after our events. If you see those really tired smiles, it is because we had been running around for 8 hours straight without a drink or a bite of food. But it is obviously all worth it because, in the end, we hear about how this is influential in our participants' lives and how they had the opportunity to meet wonderful people. Now, that said, I hand the platform over to Alka, who will be introducing the Machine Learning Paper Club. And before I hand it over, I think I would like to say a few words about Alka. Um, Alka is one of the most hardworking and dedicated people I have met in my tech journey in Vancouver. And I am so proud to be introducing her as a colleague and a friend. I have seen how passionate she is when she starts working on something that she really cares about. And I don't expect anything less than the best from her. So over to you, Alka.
Oh my God, Ria, you got me overwhelmed. Thank you so much. So, I think I have met Ria, and I would like to say the same things for her. On top of that, she's super cute. She's always smiling. I have never seen her in a bad mood. So if you're around her, you are always happy. So that's a one positive person I have met here in Vancouver. Having said that, hi everyone, good morning. Today is an amazing day at Vancouver. Finally, it's sunny after so many days. If you are from Vancouver, you can understand the pain of, not having sunny days and finally having a sunny day. So, on this one bright sunny day, let's talk about the ML Paper Club. As Ria said, this is our first paper club which we are having, and we wanted to start with an awesome topic which everyone's talking about. 2024 was all about RAG. 2025 is supposed to be all about agentic RAGs. So we thought that, like, let's start with the basic. Let's start with, hey, Dino, I'm from Vermont. Dino says I am from Vermont and I experience sunny days all the time. Oh my God, good for you, man. We never experience sunny days. Moving on. Yes, so we were on RAGs. So we would be talking about RAGs today. I would like to go through what exactly would be the agenda today. So what we would do is I will give you a little tips and tricks how to quickly read a paper. and not get overwhelmed by it, because hey, when I started reading papers 3-4 years back, I was like, how do you manage to read 4 or 5 or 7 papers in one day? I take 2 days to read one paper. So I found tips and tricks over the internet, and I would love to share it with all of you. And we would try to apply them today quickly, so that we can basically, let's see if we are capable enough to cover one paper in 1 hour. Having said that, we would have 25 minutes of discussion or internal, just simply reading the paper. We would basically divide all the sections which one paper has, and then we would come back all together and see, uh, share our thoughts on the same. But before that, I would set the stage over here. I would let you know what exactly is this paper about, so that you don't feel overwhelmed going into the nitty gritties of the whole thing. And we would be, Ria and myself, we would be participating with you. We would learn and grow together, and let's see how it goes. Let me share my screen. Do you want me to share my screen, Ria, so that I can? Yeah, thank you. There you go. First, tips and tricks, which I talked about. Before that, this is the paper towards optimal search and retrieval for RAG. As you must have seen, if you are coming from LinkedIn, you must have seen that we have been talking about towards optimal search and retrieval for RAG. This is the paper we would be talking about. It was made by Intel Labs. The whole research was done by Intel Labs and by Alexandria and Cecilia from Colorado Department of Computer Science from Colorado Boulder University. So this being said, let's like have a look of the whole paper. Initially, whenever you start reading a paper, it's important that you first gather the abstract, what exactly I'm getting myself into, and then you go ahead and see introduction. Introductions are always a great way to understand what was the thought process of the writers, or what, or the researchers around this particular paper. So till the time you are reading an introduction, you are still in a non-technical zone. Once you have read introduction, go for background. Now this background can be lit reviews in many of the papers. In this one, it's background. So and it again varies in size. I found this size to be super small, and I loved it. So I went ahead, I would go ahead and read background as well. But if you find that there's a literature review here, and that's like 2 page long, you can skip it. It's not that important. So always first introduction, first abstract, so that you know what you are getting into. Then you go for introduction, so that we know what exactly was the thought process. Thank you, Ria. I forgot to give that. Thank you for giving the link. If you want to see the paper and go with me, you can basically click the link Ria has given. Yeah, and straight away jump to conclusion. So if you go here, see how big the result is. No one has time to go and read the whole result. And quite frankly, I don't like the result section too much. So I would definitely go straight away to conclusion. Once you have read introduction, abstract, introduction, background if required, and conclusion, you have got a pretty good idea of whether or not you want to dive deep in this paper. So that is always how I prefer reading a paper. I hope everyone is basically have understood like how do we read a paper. If you have any suggestions, you can put it in the chat, and I would give you 15 seconds. If you have any questions around that, the floor is open. Going once, going twice. Okay, so let's move forward. What exactly are we getting ourselves into? I'll increase the size. Before, also, along with that, there are a few things which I would like to say in the beginning. In the, if you click the GitHub repo, So that's nothing but annotated ML papers. If I would just like to go through this real quick. Now, we would be going ahead and annotating the paper as well a little bit. I have done the introduction for all of you so that we can basically, get into this quick. If you're interested, you can go through the paper in your free time or along with us if you can keep up with the speed, because we are the slave of times over here. So if you're interested, you can annotate the whole paper, make a pull request to this repository, and we can, if we have enough papers, we will choose the best one out of them, and then we can showcase that annotated paper over here. So it's a great opportunity to showcase your reading skills, and it's a great opportunity for you to get into the depth of your favorite topic. So go check out this repository. Moving on, let's finally get to the meat of paper, and let's get familiar. You can use any PDF annotating tool out there on the internet. If you have Adobe's Premium, that's perfect. I didn't have Adobe's Premium, so I went ahead and downloaded this first link which came to me when I did a Google search. It's a basic PDF annotator, but these come with a lot of features. For example, you can basically highlight anything you want. I have highlighted here, right? So I can line also, and you see, this is how cool is this. I can, and it straightens it for me. I can make a ziggly line, it will straighten it for me. I love this feature, man. I loved it. And you can basically go ahead and highlight, as I said. You can also write text anywhere you want. So it's a cool, very cool application. If you want, you can download it. You can just make a Google search for something called PDF annotator, and you would be here. Do you have any questions around it? Do you want me to give the link of the application? Just uh, put it in the chat if you want to. Yes, you can do use Kindle Scribe. Yes, Dino. And if you have uh, iPads, you can do it on iPads natively. So that's amazing. I don't have any of them. So okay, let's get to the meat of it. I would start with the abstract. I have read it, but feel free to go through it if at all you want to. I can give you like 2 minutes and then I can basically go ahead and talk about it. Would you like to read it now or would you like me to start? Also, I can highlight things in ML paper. That seems convincing to me. Exactly. Yes, Dino, you can highlight it and you can also write side notes around it if you have something. If you want to see, I prefer diagrammatic learning. I'm a very visual learner, so I generally tend to make diagrams around the paper. You can very well do that. Coming back to the point, do you need 1 minute to go through the abstract, and then we can go ahead and talk about it? So do we have quorum here? How do you guys want to go about it? Perfect. Thank you, Sergey. Okay. So abstract. This is a basic RAG. We know what RAG is, retrieval augmented generation. And here we are basically talking only about the retrieval and how retrievals, different type of retrievals affect all the other question answering tasks down in the pipeline. So this is what exactly is being discussed in the paper in a nutshell. If we just talk about the abstract, I have highlighted this part because this seemed interesting to me. Uh, RAG addresses some of the memory related challenges associated with LLMs. Now, what does this mean? How does RAG basically, solve memory related challenges around LLMs? So what happens is when you are not providing the whole corpus or the whole data set to the LLM, then it becomes really easy for the LLMs to guess the answer, right? So that's what retrieval exactly does. Retrieval figures out small chunks of text or small sources of text, and then it feeds only the retrieved sources to LLMs and hence saving memory. So this was a cool piece of tidbit for me. Like the first line of the paper, retrieve a RAG is a promising method for addressing some of the memory related challenges. So this one sentence has a lot of depth into it, a lot of meaning into it, and that's why we chose this paper, in one go. Because this, if you go ahead and keep reading it, you will find terms which you might say that, oh, this is so cool. And that's what happened with me. So, but abstract talks only about it, only about this particular thing, and it also tells you that yes, it's a question answering. The tasks which are mentioned here for this RAG is basically the question answering tasks, and it basically talks about um, what are the different types of question answering tasks this RAG can solve. So that's all about abstract. That is a lot of information, I must say, to gain just from abstract. So if you go into introduction also talks about a lot of these things. For example, it talks about that RAG is gaining a lot of popularity because it doesn't have hallucination. So I will better do one thing. I will start highlighting. Yeah, it doesn't have it reduces hallucinations because, of course, again, the same thing. You are not feeding the whole corpus to the LLM. You are just feeding the retrieved documents or the retrieved chunks. So it has two components, as we talked earlier, a retriever, which basically identifies the relevant documents, and a generator, which basically generates the answer out of those identified documents and gives, like, spits it back to you, right? Now, what is again I found interesting, that's why I kept highlighted it, is that for this purpose we evaluate pipelines with separately trained retrievers. So that's what is being done in this particular paper, that they have basically trained different types of retriever and different types of LLM components, right? And that's how they basically um, measured and compared how different types of retriever functions. For example, it also says that in this particular paper, they will try to address the question, like, what are the weaknesses of typical search? What search hyperparameters matter for RAG task performance? So if we go down, we will see that, okay, they have answered these sort of questions. Then again, they come and say that um, they are using RAG, and they are using both standard question answer and attributed question answer. Hey, I didn't know what standard question answer and what attributed question answer are, so I just like searched it up and I made my notes over here. Here, you can make something like this. But standard question answer is something where no source is cited. For example, if you see what is the capital of France, it's Paris. It doesn't tell you anything else about it. Or then attributed question answer is where the source is cited. For example, if you have used perplexity, it's the same thing. It will give you what exactly is the answer. Along with that, it will also tell you that where in what documents did it actually find the answer. So that's what your introduction is talking about. And another thing, you can go ahead and read it. Another thing which I found interesting was gold ceiling. So we find no setting that improves above the gold ceiling, contrary to the prior report. So here I have written my notes. What I found a gold ceiling is. Gold ceiling is nothing. It's a very simple term, a very fancy term for a very simple thing called upper bound. So let's say you have done XYZ experiments and you have found that the highest accuracy is 93%. So that's the gold ceiling for you. Now, that brings me to a conclusion of abstract and introduction. And from here, we can just go ahead and choose, or we can divide you into basically, two folks in each room, and we can go ahead and read the paper. we can divide it background, experiment, and result. And if result is like not that important, so if you find something interesting out of result, you can come share your findings. And in experiment also, if you find something interesting, you can come share your findings with us, and then we will talk to each other what we found, and finally we will move towards conclusion. How does that sound, everyone? Ria, that sounds okay with you for today,
Yeah,
Sergey? Yes. Yes, Ria, sorry.
yeah, yeah. I guess we can. But we also do have few people. So you know what we could do?
Yes. Mhm.
Maybe we can set everybody as presenters, and they all can like chime in with you. Because right now I think they cannot speak to each other like just through the chat. So does like would it make sense to you if we can like if I make everybody a presenter?
Or what we can do, we can basically wait uh, a minute or two, and we all can go through each and every document or each and every section, and we can see if we are able to finish a section. And whoever wants to speak or contribute something, we can basically make them a presenter. How does that sound, Ria?
Yeah, sure.
Okay. So I think Udit has a question.
Yes. About the different types of retrievals.
Yeah. So okay, so what are the different types of retrievals? Does the type of retrieval depends on the task or data set? There are many types of retrieval systems which are available right now, and retrieval is nothing but basically getting something out of the document. So you have sparse retrievals, as I if I remember correctly. You have dense retrievals which are there, and there are so this paper discusses about ANN. I think it's approximate nearest neighbor, and it also talks about how different sort of retrievals basically affect it. The other question I think you ask, Udit, it's a very good question. Does the type of retrieval depends on the task or the data set? So there are papers available who talks about both of them. And if you go to a domain specific retrieval, and which differs in modality. If you are just retrieving texts, it has a different type of retrieval system which you might require. If you are basically doing it for some map data, which has started gaining popularity nowadays, then you have a different sort of retrieval system. But it also depends on your task. What do you want to do with a rag? We all know only about question answering. So in there you have sparse retrievals, dense retrievals, and everything which I talked about. But there are different types of RAGs which have started coming. So that also, for that there are different retrieval systems which I don't remember and I don't know at this point, quite frankly. But we you can search about it. Dino asks, for the TLDR on how to read the paper fast, what portion should we read in each paper, each ML paper? Yes, so as I said, you always start with abstract so that you get to know what exactly are you getting into. Then you go towards introduction. There they will talk in detail that what they have done, the researchers. And then you can skip lit review and background. But if it's small enough, for example, for this one it's small enough, right? So you can go into background, and you can skip it as well. I generally skip it because I don't really want to know unless I'm super interested that what you have done as a background study. And then you can basically directly go to conclusion. That will tell you in a nutshell what this paper actually achieved. And after reading all these things, if you find it interesting enough, then you can go deep. No one cares. So I hope I have answered your question, Dino. Okay. So yes, Ria, do you think we should go and start reading the background and
Yeah,
people can come in?
yeah.
Okay.
And everybody, like, as you have any pointers to share with the group, just if you can leave an emoji, or if you can, I'm not sure if this, yeah, you can raise your hand. I will make you a presenter and you can continue to share it with the group. I hope that works for everybody. Go ahead, Alka.
Yeah, I'll just go silent. I'll start a timer over here of 1 or 2 minutes, I think. Okay, let's go 3 minutes. And I can talk about it after 3 minutes, or if someone has something nice to share, they can share about it after 3 minutes. How does that sound?
Yeah, that sounds good.
Okay.
Alka, since it's just nine of us, I think I'll go ahead and make everybody, like, give them the freedom to,
Yeah.
chat. Everyone, please feel free to turn on your videos and unmute as you would like to talk. Right. I have my very clingy cat.
Hi everyone. Can you see me?
Hello.
Hi. So the so I just wanna know the main the purpose, yes, of the reading. So we just it's like to find the approach how to get information from the paper, yeah? Just
Yeah,
to okay.
just to read,
Because
discuss. That's it. Based. So the idea is to make sure that, like, we all come from very different backgrounds. So it is to relate your experiences from your background to what's happening in the paper and just share it with the group.
okay. So we will discuss the approach, this approach, what the benefits of this paper, or how to use and that approach, and yeah, how to use in our everyday life, or
Yeah.
uh, okay. So
Yeah, Alka, I think it would make sense for you to kind of skim through as we go. And then if somebody has something to add to it, they can just unmute and go ahead.
Yeah, I can totally do that. So, and just to add to you, Ria, it's like when I started reading papers, I found it really difficult. That what the hell am I doing? Like I have 8 sections to go to. How can I read the whole thing? So that's why we basically what we can do is, as I think I set the stage that what exactly this is, what exactly is this paper about. Now you can feel free to quickly go through, quickly skim through the background. If you find something interesting, you can talk about it. And other than that, we are of course here to help you, so that like in 1 hour we grasp everything about this paper. Like if anyone asks you anything about this paper, hey, have you read retrieval optimization? Yes, I have read it, and here's the thing that it talks about. So I think that's what it is. And yes, of course, every time we have this ML reading paper reading club, we will talk about tips and tricks about how to quickly read it, how to quickly annotate it. Oh, thank you, Sergey, for switching on your
Sorry, I
camera.
just found that my camera was turned off. Sorry.
Okay. So yeah, so the background basically, if you see, it has like two models, like two separate sections: retrieval models and approximate nearest neighbor search, right? And that's what the background talks about. Like they have just told that what exactly was their how they found this particular topic, what exactly is the background of it. So that's what retriever, first of all they talk about retriever, and they says that okay, they are using dense vector embedding models for the same. And they are saying that they're using presenting it as a context to a reader, and they say that yes, this reader is nothing but a LLM. So that's how we understand this, that RAG, it retrieves the documents and it generates out something out of it. But what stands in between, what document is what corpus is retrieved and where is it sent to generate something, right? So it's the LLM where it is sent to. And modernly, like nowadays, predominantly dense vector embeddings are basically used, which does nothing but it maps the documents and queries it into a vector space. Now this vector space is something nothing but a embedding, right? And this is something which there are different databases available where you can store these embeddings. And now there are different types of searches which are done. And like similarity search is the most common one which is going on, to basically identify which of the embeddings relates the most to the question which is being asked. Now here they are talking about approximate nearest neighbor search. Now which is one good thing about approximate neighbor search is that it can handle high dimensional embeddings. And when I say high dimensional embeddings, what do I mean is it can handle embeddings with dimensions greater than 1024 dimensional vectors. Like if anyone has issues in understanding, or if anyone wants me to go deep into what exactly an embedding is, I can basically very well quickly do that in like 15 seconds. Do you want to
Embedding is vectorizing the data and small into small chunks, and yeah, using this as a data in the vector format for retrieval augmentation generation. Is it true?
mostly yes.
Yeah.
So embedding is basically if you take anything and you are able to convert it into a number, that's embedding. As simple
Okay.
as that. Now, if you have a very big data, like if you have one page of
You split
data,
into
or
chunks.
yes, it becomes very high, memory intensive, computation intensive for LLMs to
Yeah, sure.
understand that. So that's why you divide it into chunks, and then you keep repeating the same process over all the chunks. You
Yeah.
convert every chunk into a number, and then you do the same thing with a question answer. Like I am going as layman as possible here. Like you do the same thing with the question as well. You convert it into a number, and then you see that that question's number, how similar it is to each and every embedding which is there from the corpus. And that's where retriever comes into play. What it does is that from that particular question, it chooses like top 10 or top 20 chunks or embeddings, and then it spews out the answer, then it feeds that those chunks to a generator, and then it creates the answer out of it. So that's exactly what they are talking about, that what are the different methods of retrieving something, and what are the different methods of doing that particular search we have been talking about. And ANN is amazing. It is basically, it has a good speed also, and it's kind of accurate also. Like similarity search, it's very speedy, but it's not that accurate. It can hallucinate a lot. I have
Mhm.
used similarity search and I have seen it giving bogus answers. So that's what the background is talking about. Now, if you read it exactly, you might find issues around it. You might have more questions around it, and that's what this we are trying to achieve over here. For example, I just found an interesting um, uh, sentence. So it says that modern vector embeddings contain greater than or equals to 1024 dimensions, resulting in severe search performance degradation due to the curse of dimensionality. This curse of dimensionality, if you ask, it's one chapter of data science, and they have basically talked about it in like what, 3 words. It's as simple as that. That's what we want to gain out of it. You find some words like this, you ask questions around it, you search around it, and then you make notes around it. So for example, if I see curse of dimensionality, I'll make a note around it. Text, right? I keep forgetting the, yeah. What is a curse of dimensionality? If dimension dimensions of an embedding keeps increasing,
Mhm.
then it starts losing. What does it start losing? It starts losing meaning
Accuracy. Mm.
in the vector space. This is one of the curse of dimensionalities, that it starts getting so sparse, because you can like if you can visualize it, it's difficult to visualize in 1024 vector dimension space. But like if you think in 2 dimension space, for example, I have 2 points like this, right? I have 2 points like this. Now you make it 3 dimension, I might have 1 point here and 1 point here, which if you project it in a 2 dimension, it will come here. So if you keep increasing the dimensions and not project it, then it starts getting so sparse that it starts losing its meaning. And that's what the curse of dimensionality is. It is one of the curse of dimensionality. There are like 3 4 curses, and it's a very interesting matter to me. So I would like, if like we are continuing this, if you join more paper clubs of ours, we would like to find issues like this, and we would like to dive deep. We are okay digressing from the paper altogether. It's completely fine as long as we are learning. So any thoughts about it, Ria? If you have any thoughts, you can like basically share.
No thoughts. Need to understand this paper more. Like a home task.
Yeah. No, of course, of course. So I think we have set a
I do
precedent.
have a question though.
Okay.
It's slightly unrelated. What's the difference between ANN and KNN? Like, what's the approximate part of approximate nearest neighbor search?
I really don't know. It has to do with some formulas. KNN is basically nearest, in the most basic form, nearest neighbor search, right? What it does, it takes a point and it basically, I think it does a square of some distances
Yeah,
between all the points. And ANN is might be some other formula. If it would have been talked around in the paper, I would have read about it.
I see.
So
Okay.
you can any that's but that's the kind of question, so that we can basically search together. Like, you know what, let's search it. uh, Difference between ANN and KNN. Cool. Gemini is here to help us. Let me just project the screen.
Have more speed and efficiency.
Yeah, but this is not what we want. This is not what we want. This, we know that speed and everything, what exactly is the differences, right? So again, here, this is a very good example of the retrieval system. Prioritizes speed over exact precision. So of course in KNN we know that it calculates the distance, but in here probably they might have a different sort of statistical formula to not exactly go ahead and see the exact distance, but probably it just prefers a speed, probably it stops after a certain number of iterances. That's what I can uh, guess from here.
I see. Like in KNN, instead of trying to find the closest neighbor of a certain point, you can, rest at, if the error is under a certain threshold, we are good to go. So sort of an
Probably
approximation.
yes. So it might has to do a lot with epochs. Mostly
Hmm.
when you are trying to achieve, that's again, how do we make a calculated guess at all in data science, right? Um, if you are trying to achieve, for example, if you have trained your own models, you would remember that if you are trying to achieve a certain level of accuracy, for example, I know that the golden accuracy for a certain task, let's say for YOLO, is 93%. I know that for on CFAR data set, YOLO achieves 93%. My data set, I am going till 92%, but I have my patience threshold set as like 4. So if it keeps decreasing from 92% to 91, let's say it keeps dwindling, but it's still below 92% for 4 or 5 epochs, I'll stop training, right? That's what
Yeah.
patience does for you. And I think it's the same thing which happens in ANN. It keeps on finding the distance, but after a certain epochs, it says, you know what, I'll stop. No, I'm good. I wanna have speed. So that's what it does over here. That's what it's trying to do. And again, if we read more, we will probably know more, right? So for example, we in retrieval, what sort of retrieval is it doing? I will let me select the highlighter. Yeah. We chose to evaluate two high-performing open-source dense retrieval models. For single vector embeddings, we relied on BGE base to embed documents. We used Intel SVS library to search over the embeddings for efficient dense retrieval. So it has done for single vector embeddings, BGE base, and for higher dimensional embeddings, dense retrieval, exploiting its state of the art based ANN search performance. Now, what exactly is ANN search performance, as you asked, is in the citation number 21, right? So let's go to citation number 21 and I'll open that particular similarity search in the blink of an eye with compressed indices. Ah, it compresses the indices. That's how it figures out. Oh, sorry, I didn't. It's easier for me. I have a Adobe PDF open right by my other screen because it's easier for me to click and go. So yeah, here, similarity search in the blink of eye with compressed indices. So here, if again, we will do the same thing. But again, this is what I didn't want to go, because I have a habit of going into a rabbit hole when I'm reading papers, and I did not want to do this with all of you. But let's do it. Yeah, let's quickly read it. Yeah, that's what, let's see how quick and easy it is to read a paper through that one. And pardon my mumbling, I'll start mumbling pretty quick. Or okay, so yeah, nowadays data is represented by vectors. Retrieving those vectors among millions and billions that are similar to a given query, ubiquitous problem. Yeah, exactly. As we were talking about similarity search, graph-based indices are currently the best performing techniques for billion scale similarity search. However, their random access memory pattern presents challenges to realize their full potential. In this work, we present new techniques and systems for creating faster and smaller graph-based indices. So that's how I think ANN solves the problem, using graph-based indices. To this end, we introduce a novel vector compression method, locally adaptive vector quantization LVQ, that uses per vector scaling and scalar quantization. Perfect. I don't want to read anymore. I think we have got everything what we wanted, but let's quickly go to conclusion as well. Beautiful. Load. Come on. Yeah, there we go. Conclusion. We presented new techniques for creating faster and smaller indices for similarity search. We introduced a novel vector compression method, locally adaptive vector quantization that simultaneously reduces memory footprint. Wow, and improves search performance with minimal impact to search accuracy. Oh my God, nice. LVQ is designed to work optimally in conjunction with graph based indices, reducing their effective bandwidth while enabling random access friendly fast similarity computation. So there you go. To answer your question, Udit, how ANN works is it uses graph-based indices and it uses LVQ, that's locally adaptive vector quantization techniques. So I think we all learned how to quickly read a paper, and but we also learned that we should not go into this rabbit hole. You're doing research, don't go into this rabbit hole. I think Ria has done
Yeah,
a lot of
man.
features. She's familiar with this. Ria, any thoughts?
Yeah, I like, I mean, it's so easy to lose focus of the paper that we're reading.
Yeah.
I guess never like always set a time limit to how much you will read a new paper. Um, if you are focusing on one, only read the abstract and conclusion of the new paper that you're trying to investigate from, because like they have gone through the effort of finding things for you. Always try to come back to the paper. Anyway, speaking of which, we have another 8 minutes, maybe just to wrap up,
Mhm.
and then yeah, we can go on from there. So, can we
Yes.
go to the results and just talk about the our final thoughts about the paper?
Do you think what we can go to conclusion because
Yeah,
results is like 4 pages
yeah,
long?
yeah, yeah. Sorry,
Yeah.
sorry.
So
Conclusions.
let's do one thing. Um, if any one of you is interested, then you can go through data sets, metrics, create an annotation around it. If you are even more interested, you can create annotations around introduction and background and everything, and you can submit a pull request to our GitHub repository. We will definitely, Ria and Preeti are amazing, hardworking people in GDG Surrey, and they have given me this opportunity. So they will definitely choose the best one, and they will I will work along with them to make one single annotated PDF out of it, and we would definitely give the credit wherever it's due. Having said that, let's go to conclusion. Uh, I hate graphs and numbers and everything because it. Oh, I was in appendix. I was traveling in appendix. Yes, there we go. So yeah, conclusion. Does anyone wants to read conclusion? We have it's 11:23. We can be here for like 2 minutes, and then in last 5 minutes we can wrap up. Going once, going twice, going thrice. Okay, Ria, do you want to
I think you can go ahead. It's okay.
read? Ria was like, I made a mistake coming here. I'm
Go ahead.
so
Go
done
ahead.
with reading papers. But I don't know, man. I find it really interesting. I read papers for fun sometimes. Anyhow,
Yeah.
overall, our experiments suggest that models can retrieve a higher number of gold documents will maximize question answering performance. You know what? The first time, fun fact, the first time I read this, I read it quality analysis. It's like, how do you get quality analysis done here? But then I Googled and was like, oh, it's question answer. Oh, sorry. Okay. We can observe that leveraging ANN search to retrieve documents with lower recall results in only slight QA performance degradation, which correlates with a very minor change to gold document recall. Basically, they are saying that if you use a gold document, okay, one more thing. What's a gold document? Quickly, so gold document is the document which has the exact answer. Those are the gold documents. What's the capital of France? If a document has has these words, a capital of France is Paris, that's a gold document. So yeah, It says that even if I'm using ANN with lower recall results, then there is a really slight question answer performance degradation. It doesn't have a lot of effect. Thus, operating at a lower search recall regime is a viable option in practice to potentially increase speed and memory efficiency. We also find that, contrary to the prior study, which you can go and see, I'm not going to go down the rabbit hole again, injecting noisy documents alongside gold or retrieved documents degrades correctness compared to the gold ceiling. Yes, so they are saying that if you are leveraging ANN search, and if you are, there are there are different experiments they might have done. If we had time to go through the experiments, we would have seen that if you are basically using ANN, or if you are using noisy documents are the ones which degrades the performance more than using a certain type of search, or retrieval regime. Moving on, we also find that it has an inconsistent effect on citation metrics. This suggests that the impact of document noise on RAG performance requires further study. Future work should test the generality of these findings in other settings. Understanding how approximate versus exact search affects multi-vector retrievers, such as, would be interesting. Okay, this is cool. Understanding how approximate versus exact search affects multi-vector retrievers, such as, would be interesting, especially given their general good performance. Now, they must have a different papers that they might have cited. Oh, they have, sorry, which talks about the same thing. How basically you can have exact search and approximate search, which we have done over here, and how it basically affects the retrieval part of RAG. Now, RAG systems are trained end to end, which is a very difficult thing to do. Here, they have not done that. May rely less on gold documents, such as retrieval metrics are not useful relevance markers. So that's what they talk about. They are saying that it doesn't affect a lot, but when you compare search performance, search type, and the type of document matters more than the type of search. So that's what they have achieved from the whole paper, but in a much more technical manner. We could have gone through that. If anyone has any thoughts around it, they are welcome to. The floor is open for you.
What is fusion in decoder?
Where do you see that?
Uh, Near the rack system trained end-to-end, AG fusion in decoder. What's FID?
Uh,
It's specific
RAG
model?
fusion in decoder FID. Yes, it's a specific RAG model. Specific RAG model for retrieval, not for, like, when we talk RAGs, we should talk retriever and generation separately.
Mhm.
I do have a question on noisy documents.
Mhm.
What's the point of injecting noisy documents? And was it surprising that injecting noisy documents degrades the correctness?
The point of injecting noise is, uh, okay, I can think of 100 use cases right now. For example, you have military grade document where they have injected information there, one or two information there, which they think that if I inject this information, it might not be readable, sort of. That is one thing. I think you have heard about needle in a haystack evaluation. For example, you have a document where you have talked only about water in that document, but one thing talks about people. So are you able to find that answer? That injects noise. um, or let's say you have a document where a lot of things are being talked about. Is that going to affect? So in literature world, you have all sorts of documents, right? It's not always clean and pristine as you would see in a,
Mm.
legal tech industry, or especially in environment tech industry. You have people going all over the place in their documents. So that is exactly the, use case, I would say, Udit.
And how do we define noise here? What exactly is noise? Is it like anything which does not have answer to the question that I asked to the
Yeah.
RAG?
If I could just add, the
Yes.
reason why we put noise into models is to make sure that we have like randomness. in our model training. Why do we need randomness? It's so that we have generalization in our answers. Now, the thing is, we can teach that a model that the capital of France is Paris, but we cannot go ahead and teach a model everything about everything. But that is why we add noise. We are kind of giving it some room to kind of think for itself in a way. Again, this is like over generalization. This is not actually how it works, but this is how we can understand as human beings. It's like giving a child that this is this and this is this. Now what could this be? So when
Hmm.
you add noise, when you add that variability factor, you're actually making the model I don't want to say intelligent or like intelligent.
That makes sense. It essentially prevents specialization of a model. But essentially, the
Yeah.
noise here is anything uh, which is
Nice is actually
irrelevant.
wrong answers. That's why, like, it is not a surprise that it degrades performance. In fact, that is actually what we want. We
Yeah,
don't want the model to be 100% accurate. We want it to be a little inaccurate.
Yes.
So this is kind of it is in the direction of what we want.
I see.
Mm.
So you say noise is basically if I say somewhere that the capital of France is New Delhi, so that's
Yeah,
noise.
yeah,
Oh,
it's nice. So it's like it's just to make sure that the model in the end chooses Paris itself.
oh.
Yeah.
But
All
how will
I
the
think,
model figure out what's the correct answer? I mean, if you
We
feed,
have taught it initially, and it's
yes.
kind of making an educated guess. Okay, so how guessing, okay, like how a model gives you an answer. Model giving you an answer is a game of probability. The model has a bunch of answers. It also has probabilities assigned to it. And then it just goes to the highest probability.
Mm.
Now, with noise, what we are making the model do is that so just because it has the highest probability, this highest probability could be like 0.004 or something. It has no sure like assurance of what the answer is. By adding noise, what we're doing is that we're making sure that that final probability is a valid probability. It's something that is closest to the right answer.
and where are we exactly adding this noise? Is it in the data set?
Yeah.
Yeah.
I see.
And I think just to add to you, I think uh, noise, we also train RAG in a way that you should know how to navigate noise. Is there a certain type of type or a retriever type which works on noise well? For example, similarity search we have we have seen that doesn't work on noise too well because it basically does embedding matching, right? So that's why they go for ANNs and everything. Okay, so finally at the end of the day, these are nothing but statistical formulas. So we also are, if you see it from a bird's point view, we are doing nothing but we are doing hit and try. There is there are exact formulas, but still now LLMs, RAGs, or machine learning is a black box. We don't know what exact formula to give to get the right answer. We are doing hit and try. So there is, if you ask questions like, uh, how are you sure that this is the formula which this ANN works perfect on this sort of noise? We don't know. We don't know the how. We just know it because we have done enough experiments around it. Okay.
Alka, we have crossed time,
Yeah.
so I think we'll wrap it up. Do you have any final thoughts to share?
Thank you everyone for joining. Uh, it was actually fun going through it. I too had gone only through 50% of it. I thought that we all will go together. And we did that in conclusion, and it was amazing. Thank you, Sergey. Thank you, Udit, and everyone for joining the ML Paper Club. And if you want to, you can talk about it so that we have more people joining in, so that we have more things to discuss about, and we are digressing the paper more. And if you have any sort of you know, if you have a specific paper in mind which you want to go through, you can do that. We can post polls also on LinkedIn. through which you can basically um, select what paper you want to go through. But if you have something specific, you can put it in the chat right now, and we will be sure to take that up.
Okay,
Another
so I
thing
can
I
propose my own, not my paper, but paper that I focus on. Yeah.
yeah.
Mhm.
Okay.
Another few things to add is the next steps that you can take. So one thing that you can do is, as a participant, you can go ahead and annotate this paper according to how you feel fit, and share it with everybody in GDG Surrey by creating a pull request. The details on how to create your first pull request, if it is your first, is there in the README section of the GitHub repo. The next thing is, if you are part of our Discord, we can go ahead and discuss what paper to do next. And as I mentioned in the beginning, GDG Surrey is community driven. Everybody is welcome to start, um, like,
Mhm.
if you want to initiate something, you are welcome to do that. You can send us an email or even just text us on Discord. If you would like to lead a paper reading, that is also okay. We welcome all of you to do things like this. And these are your three next steps. It is making a PR,
Mhm.
joining the Discord, and if you have any initiatives, go ahead and let us know. We'd be so happy to orchestrate it for you like this. And with that, we come to the end of today's session. Thank you so much for joining, everybody. Alka, if you'd like to share your any kind of way to keep in touch with you, your LinkedIn or your email in the chat, please feel free to do that. Everybody, Alka is an amazing human being. Feel free to connect with her. She loves learning and she loves learning together. Thank you so much for joining, and see you in our next event.
Thank you, everyone. Thank you, Ria. Thank you for hosting this and giving me an opportunity to lead a ML paper club. To do something which I love doing publicly means a lot. So, thank you. And hopefully, see all of you next week. We are trying to make this a bi-monthly thing, and let's see how many of recurring faces we see in the next stream. Sorry, next club.
Okay.
Thank you.
Thank you.
Goodbye.